This video is on the inverse of a matrix. Let's just start with a basic equation, something that you've seen before. 3/2 x equals 15. How would you get the 3/2 on the other side? Well, you would multiply by 2/3 on both sides. So that means that x would equal 10. Well, you've known for a while what a reciprocal is, but let's say you didn't know what the reciprocal was. If I put 3/2 in the calculator and use the inverse button, which is x to the -1, that's called the inverse button. If I did that and press enter, I would get 2/3. So we want to do the same thing with a matrix. Let's just come over here and look at the matrix equation. Okay. So if I had a matrix like this, let's say this was matrix A and this is matrix B. What I would do is enter these into the calculator. Okay. Now, this is a multiplication right here. So I want to put matrix A over on the other side. So what do I have to do with matrix A? I have to inverse it. Okay. Instead of dividing, we're not going to call it divide, we would call it an inverse. So that's how I'm going to write it. A inverse times B. And that's actually how it's going to look in the calculator as well. When you do your calculator, if you've seen the video on how to enter a matrix in the calculator, you're going to go and select, after you've entered A and B into the calculator, you're going to go and select A, and then you're going to get your X inverse button, and then you're going to multiply, and then you're going to select your matrix B. After that, you'll be able to find your answer. Okay, now let's just add one more thing onto this. Notice that I wrote A inverse first and then B. It's because the dimensions have to work out. Remember, when multiplying your columns, your number of columns must equal the number of rows. So in order to do that, the A needs to be in front of the B when putting it in your calculator, or you will get a dimension mismatch. Okay, let's go on from here. We're going to close this video and we'll do another one on how we can use this matrix equation and the A inverse B to solve linear systems.